Hello. Yeah, good morning, everyone. Uh, my name is Rajkumar Jain. I am based out in Excel Point, Delhi, handling microchip application product support. So, hope I am audible to all, right? Anyone can confirm if my audio is audible to all.
Yes, you are, Raj. Go ahead.
Yeah, thank you. So, first of all, I welcome to all to this webinar, one of the interesting product webinar which we are having with our microchip experts. So this is SiC Power Solutions, Silicon Carbide Power Solutions, where we can learn how to adopt these products with ease, speed, and confidence. So before we start, I would like to introduce the speakers and the panelists which we are having with us in the panel today. So first of all, I would like to introduce Mr. Mushin. Mr. Mushin is from Microchip, and he is group leader Asia for the analog and power electronic function group in Microchip technology. He is based out in Bangalore, and he leads the all analog and power function group engineering team of Asia Pacific region in Microchip office. He's having good expertise in power electronics and analog design, and he's having good experience of approx 10 plus years. Apart from him, we have Mr. Perumal. He is a senior engineer field application in Excel Point India, based out in Bangalore. He's also having 8+ years experience in power electronics design and development. Apart from these two speakers, we have Mr. Santosh Pachwal. He is from Microchip Bangalore, and he handles all the channel operations in India. Apart from him, we have Mr. Shirag. He's from Excel Point, and he's handling the product management activities in Excel Point India. And yeah, so these are the panelists and the speakers with us for the webinar. So we will be starting in another 2 minutes. At 11:05, speakers will start the presentation. So before we start, I sincerely request that we are having Q&A box. At the end of the session, we'll be addressing all the questions. Okay. And if you are having any question, please write in the Q&A box. At the end of the session, our panelists along with the expert will address the question answers. So right all, good to go. Over to you, Machine and Perumal. We'll be starting in another 1 minute. Thank you.
Is the screen visible?
Yes.
Yes, Moses.
Okay. And I hope my audio is also clear.
Correct.
Yes.
Thank you.
Just to save the bandwidth, I request all to switch off the video apart from the speaker.
Yeah.
Thank you.
And if it still crosses the trouble, then let me know. I will also turn off the video. Okay.
Sure.
Okay, I'm waiting for your green signal. I'm ready to start.
Okay, guys. So yeah, Moshin, good to go. We can start now. Thank you.
Okay. Thank you, Raj, for a very nice introduction. And thanks, everyone, for joining us today. As the title indicates, we're going to spend a lot of our time in understanding Microchip's SiC power solutions. Solutions from Microchip, but then today that's information that would help you to understand how Microchip SiC can be your design, or SiC can be part of your design with ease, speed, and confidence, right? So that's the theme that we have. This is the quick look at the agenda. We will begin the session by a very short overview about Microchip and Microchip's analog world story. And then we'll talk about why is silicon carbide as a hot topic of the season. And then we'll talk about why Microchip silicon carbide, and then quick look at the portfolio, some of the supply chain. I mean, everybody's talking about lead time issues and all that. So we'll also let you know how we are addressing that. And then we'll also talk about some of the simulation and designs, ecosystem, and then we will summarize. right? So let's get going. This is a very short summary of what is Microchip today. Microchip used to be a digital and memory company about 10-15 years back, but that's not the case today. We are today a total system solution provider. That includes a very high performance microcontrollers, digital signal controllers, and processors. We are one of the industry leaders in mixed signal, analog, interface, and security solutions. Apart from that, we also have a lot of clock and timing solutions, wireless and wired connectivity solutions. We're very strong with our FPGA solutions and also the memories and flash IP solutions. So it's a very, very brief. If any of you are unfamiliar with Microchip, I would request you to take a look at our website. That's microchip.com, and you would be surprised to see a lot of portfolio that Microchip contributes today. We are at around more than 6.5 billion revenue run rate, and we are headquartered in Phoenix, Chandler, near about 20,000 plus employees and 120,000 plus customers that we are serving today. This was just to give you a brief about what Microchip on a corporate level. Now, if you look at the analog story of Microchip, we are today one of the leading analog supplier. The reason why I emphasize analog or power electronics department today is because SiC comes from that. And I want you to take or to have a very good impression about or very good understanding about what is Microchip's analog kit. So the titles that you're seeing in the screens are basically the basic portfolio that Microchip provides today. That starts from a very simple LDO to very complex silicon carbide or its gate drive technologies and all that. And of course, we do also have a lot of linear and mixed signal devices. We are the industry leaders in thermal management, and the story goes on. Some of the highlights for your understanding: we are a leading analog supplier with a very high growth rate that contributes to about 25-30% of Microchip's total business is from analog. And that business figure is actually much higher than some of the dedicated analog semiconductor companies itself. We have a collective experience of more than 60 years in the analog product development and design. That's actually because of a lot of acquisitions that we did in the last 5-6 years. Micrel, Supertex, Microsemi are some of the big names in that acquisition, which contributed largely into the analog portfolio from Microchip, right? We are the industry leaders of LDO, switch remote converters, op-amps, temperature sensors, and SiC, the topic of the day, right? That means we are the leaders by the specifications, the wideness of the product catalog, the business wise, and it's a multiple dimensional title, right? But then I would request you to think of Microchip when you're thinking of such analog devices. We are a proven automotive and high reliability supplier. That is a key point, because it takes a lot for a supplier to become a proven and somebody with a long history of supplying in automotive and high reliability applications such as aerospace and defense, right? It's not an easy job to do. It requires a lot of testing facilities and multiple skills and certifications and all that. And today, Microchip is also providing a very comprehensive analog support ecosystem that includes our field application team, includes our internal application team. It also includes our development kits, the analog simulation platforms, the library supports that we provide. That includes everything, right? So today we have managed that very well for our analog portfolio. So that was a quick glimpses about the Microchip's analog world and also the corporate overview. Now let's jump into the topic of the day. So the SiC comes from our power MOSFETs portfolio, the high power discretes. Let's begin by addressing a question. Why is SiC, right? Why SiC is required at all? This itself is actually a couple of hours topic to discuss, but I have actually made it in 2-3 slides. I hope that works. So the applications where the high power MOSFETs are typically for the high power converters, inverters, that are meant for industrial, automotive, and high reliability and high efficient applications and all that, right? Now, all of you know that all of such power electronic designs requires or it keep requiring, or it is an ever increasing demand in power electronics world to have an improved efficiency, reduce its cooling needs, decreasing its size and weight, and stricter EMI and RFI requirements, and also improved power quality requirements such as power factors, better ripples, less noise emissions, and all that, right? This is ever increasing demand. Now, all of such improvements are greatly influenced by the properties of the power switch or the MOSFETs or IGBTs, right? This is something, it's very evident. I don't think there is any debate about it. But now, which of the properties of the power switch are very critical for such improvements? One is that everybody needs a lowest RDO zone and lowest switching loss devices. Everybody needs high power dense devices, then capability to switch in a very high frequency, and also better thermal conductivity, right? These four critical parameters contributes very largely into the improvements that power electronics engineers seek for in their design. Now, such properties for a silicon MOSFET, it has reached to its kind of or near to the saturation. There are all sorts of technologies and by the construction methods and all that, everything is available today. So there is a limitation for the silicon MOSFETs to improve again, right? So that's where the answer comes as a wide band gap devices. Why is wide band gap devices required? We will analyze that in a minute. But what are such wide band gap devices? Those are silicon carbide and GaN FETs. Now, out of that, silicon carbide has been proven. It is proven in the field, proven by the design, proven by the production and all that for the high power and high voltage applications. GaN is on the way to prove itself for the high voltage and high power applications, but then for the mid voltage and high power and high frequency application, GaN is also as a good fit. Now, we are talking about SiC today because we believe that SiC is the ideal candidate for the high voltage, high power applications, right? So we just said that wide band gap devices or SiC is good. What it makes SiC so good that it is better than its silicon counterpart? For that, we need to analyze this diagram. And as I said, I'm not going to the in-depth of analysis of this diagram, but then why I have this slide is because every time when we think about why SiC is so better in terms of its properties, then if you keep digging in, then you're going to end up in this particular slide, right? Because all the advantages we have because of SiC, it's primarily because of its construction or the physical structure itself. It's a physical structure of the MOSFETs, right? So the left extreme, what you see is the silicon one, and then the right one is silicon carbide. So it's basically what it says is that it has got an additional layer of N-type silicon carbide. It's a material. It's a silicon marrying carbon that becomes silicon carbide. And when at the die level or on a wafer level, you grow the MOSFET on a silicon carbide material platform, right? And that's when we get a lot of advantages. What are such advantages? That is enlisted in the table on the right extreme. The number one advantage we have is the breakdown field 10 times higher compared to its silicon variant. That means for the same device, you can imagine one TO220 MOSFET in your hand, right? If the same device is a silicon carbide, then its capacity or its breakdown field becomes 10 times better. That also means that if you want to have the same rating of the voltage, then you can reduce the die size by 10, right? Or you can reduce its area to a larger extent. That actually improves or saves a lot of path for the current flow. Ultimately, it's a resistance reduction. So the RDS one becomes less and you end up in getting a better efficiency. Similarly, the velocity of the electron, right? The flow of electrons is what the current flow, right? So the velocity of electrons is also 2 times higher. That indirectly says is that you can now increase your switching frequency. Some of you at least know that the high voltage, high power IGBTs are limited its switching frequency to, for a very reliable operation, it's about 20 to 30, maximum 35 to 40 kilohertz, right? Now here with silicon carbide, you can even go to 100, 150 kind of kilohertz easily without any reliability issues. Now the band gap energy also contributes to have the improved cooling and the thermal conductivity. Of course, that gives us a very high power density use cases for the silicon carbide. So it's all basically the message is that the difference is because of its construction itself, its physical structure itself, right? If I map that to the system level advantages, the similar table is what you have seen in the previous slide is actually on the left side of the screen. Now, this slide shows you how to map that into the system level advantages. So the band gap improvement as well as the breakdown voltage improvement will enable us to have the high voltage operations, right? I mean, you can use these devices even for 3,000 volts kind of applications in a very reliable way. You don't need a lot of additional circuitry for that. Now, the electron mobility or the electron velocity that is helping us to have the higher switching frequencies that in a way contributes, or for a system benefit, it reduces the size, reduces the cost, and also reduces the weight. Similarly, the story goes for the thermal conductivity. You don't need a lot of cooling or the big cooling methods. Of course, you would need some, but then you can reduce such cooling stuff in your total system design, which also helps us in having the reduced system cost and weight and all that, right? Now, where is SiC positioned in the MOSFET spectrum? I call this as MOSFET spectrum because the x-axis is it's the voltage ratings and y-axis is the power ratings. The green one is actually the area where we prefer silicon carbide. It is not that silicon carbide will not work below that green one. Of course, it will definitely work. But then if you consider the cost aspects, the complexity aspects and all that while you design the system, then we believe the green area is where the SiC fits. The red is for the GaN and the yellows are for the silicon-based MOSFETs. Blue is definitely for the high voltage and high power IGBTs, right? So SiCs are suitable for anything above 600 volts and anything above 3 kilowatts or 2 kilowatt and above kind of power supply designs. And these days, we're also getting a lot of a design requirement for not only for the switched mode applications, but also the channel enable disable type of, or the eFuses type of applications, right? So then, of course, there are case-to-case differentiations apart from this graph, but this was actually a general indication of where the SiCs are placed with respect to the voltage and power level. So we just addressed why silicon carbide. Now the next question is, Microchip is not the only silicon carbide supplier, but then why Microchip silicon carbide can be a good device for your system design, right? Let's look at that. Before I get into the why Microchip SiCs, let me quickly introduce you about our product portfolio. Today we have the dies, we also have the discretes, modules, and gate drivers. Our voltage capabilities ranges from 700 volt to 1200 volt and 1700 volt. And also today, we have recently released our 3.3 kilovolt devices. We also have current ratings that all the way up to 500 to 600 amps on the very higher side with the modules and all that. But then, of course, we do also have the low current discretes, right? So it's industry's biggest catalog in terms of SiC devices. We'll talk about the portfolios in a detailed way in the coming slides. This was just to give you an introduction about our portfolio. Now, as I said, why Microchip SiC? Microchip SiCs are very famous for its ruggedness and reliability. Because, you know, we are playing in a harsh environment. The di by dt, the dv by dt, the switching frequencies, the power levels, voltage levels, everything is critical. Everything is high, right? So it's a very harsh environment for any power discrete to perform. So that's where our ruggedness or the reliability of Microchip's devices becomes very, very important feature. The very first one is our gate oxide integrity, then our body diode reliability aspects, and our avalanche ratings, and also our short circuit withstanding capabilities. I'm going to get into all of these points in a detailed way. Let's begin with our gate oxide stability. The gate oxide stability is, in simpler terms, it is the stability of your gate to source, that oxide layer, right? So again, all my explanation, I would take an example of that. You're in a virtual world. So for that, assume that you have a MOSFET in your hand, and how do we understand its stability, right? So for that, you're gonna bias the gated source with, for one first test case, you're gonna bias it with a negative 8 volt, and in the second case, you're gonna positive bias it with some 20 volt. So for this test, you're gonna keep it at negative 8 volt or the minus 8 volt, and you're gonna keep it for maybe thousands of hours. And then after keeping it for thousands of hours, you again take that MOSFET and see whether the threshold level of that MOSFET is changed or not, right? So that's the test case. So even before the test or before the stress test, you have to see what is this threshold level. And after keeping it for thousands of hours, you're going to again come and see what is the, or you can easily test, right, the threshold level. So if there is a delta, or if the delta of that threshold levels before the stress test and after the stress test, if it is large, then we consider it as an unstable one, right? I mean, it is not meant for, or it is not very good for a very reliable operation that needs a lifetime of tons of years, or or high amount of years. So that's the first case. Now in the second test also, for the gate oxide stability, then the second test also, we will keep the gate to source biased with 20 volt and keep it for thousands of hours, and we see if the threshold value is changed. How do you test the threshold value? What is threshold value? It is basically when the MOSFET start turning on, right? So it's easy to test. Now Microchip did that testing, and we saw that the delta is only less than 0.02 volt. From all the theoretical calculations, not only done by Microchip, with the help of many other universities and many other semiconductors and all that, unanimously agrees that if the delta is more than 0.1 volt, then it is highly unstable one. If the delta is, or the change is as low as possible, that is the best stability that you can have with the gate to source stability, right? And it is very, very critical because all the considering all the undershoots and overshoot and all the parasitic capacitance and all that comes in the design, gate oxide stability plays a very large role. And today we know that Microchip is at its best, or industry's best figures with respect to the gate oxide stability, right? That was about the gate oxide stability. Second one is about the body diode stability. As you see on the right side graphs, which is basically the VI curves of the body diodes of different suppliers, and also towards the end, that's about the Microchips, silicon carbides, body diode VI graph. Again, the test is done in such a way that it kept in biased for 10 hours, 20 hours, hundreds of hours, and all that. In a biased way, and 3.5 amps or 5 amps will be continuously flowing. And you can see that the VI graph of other suppliers is being degraded, right? Or there is a performance shift, which is not good, right? I mean, you can't rely on the body diode. Then what you would do, you will have to add an extra anti-parallel diode, right? So here Microchip offers that ours is a stable one. There is no degradation at all observed. Now, when I say, is this all tested by Microchip itself? No, that's not the case. We don't believe in that, testing by ourselves and then benchmarking it. Rather, there are a lot of universities in US as well as in Europe who does the power discrete benchmarking. They did that, and the data is also available from them. So in case if anyone of you are interested, we can get the very detailed report. So we believe that we are number one in terms of the body diode stability compared to any other supplier, because there was no degradation observed at all. Now, the other ruggedness factor or the other critical feature is about our short circuit capability. When SiCs were introduced in the early stages of SiC introduction, about 5, 6, or 8, 10 years back, the short circuit capability was one of the concern. But then, including Microchip, everybody solved it. Today, we have the industry's one of the best figure, that's about 10 microseconds withstanding on a 350 volt drain to source application. So our MOSFETs are designed to survive short circuit events. Again, the detailed test reports and all that's available, but we believe that gives another golden feather in our hat about the ruggedness is concerned. Another one is definitely very important one is our avalanche capability. What's avalanche capability? It's basically it determines whether your MOSFET would turn on in the unprecedented situations in terms of high voltage and high current events, right? How do you measure the avalanche capability? So there is a very one famous test called repetitive UIS test. UIS stands for unclamped inductive switching. In this case, what happens is the inductance, or you can again assume that you are in a lab. What you would do is you would charge a certain amount of inductance, let's say 1 millihenry, and then you would discharge against or across the drain to source of the MOSFET without any clamping, right? So you charge the inductor and you have the drain to source of the MOSFET connected and you discharge it across it, right? So typically what happens, the high amount of energy is applied across drain to source of the MOSFET, and we would see how long the device withstands it, right? Microchip's devices withstands it to the longest compared to any other competitors. Again, these tests are not done by Microchip alone. The reports are available from different benchmarking universities also. And we are number one in terms of our avalanche capability. And this capability allows us in reducing again a lot of numbers. Confidently, you can use it with a very limited amount of buffers in terms of the high voltage attacks and all that, right? So this gives another edge or another confidence factor in terms of in our design use cases. Another critical one in terms of ruggedness is our RDS on stability with respect to temperature. I don't have any claim that we are the lowest RDS on SiC supplier in the market, but then we definitely are the best stable RDS on one with respect to temperature. Because typically RDS on varies a lot with respect to temperature, but that's not the case with Microchip SiCs. This is data for 1200 volt devices compared to their different competitors. Now, this is also very critical because we have seen in many designs where the RDS zone value is used for the current sensing, right? Then you would end up in using the thermal compensations and all that in a design. But with Microchip, you can eliminate some, or you can at least reduce the criticality of such circuits. You could see the graph is pretty stable compared to our competitors with respect to the temperature change from negative degrees to all the way up to 150 degrees, right? So that's all the ruggedness and reliability aspects of Microchip silicon carbide products that I wanted to share with you. I spoke about the gate oxide integrity, also spoke about the body diode stability and the avalanche ruggedness, and also the short circuit capability, and additionally the RDS zone performance with respect to the temperature, right? So that's about our ruggedness part, and we just addressed two questions: why silicon carbide and why Microchip silicon carbide. So next is to have a very quick look about our SiC product portfolio. As I said in the beginning, we have multiple type of portfolio. The first one is silicon carbide discrete, just like you see in the pictures. It's basically our very favorite TO220, TO247, or SOT227. Those type of packages. We also sell dies, by the way. We also have it. And the voltage ratings, as I said, it ranges all the way from 700 volt to 3.3 kilovolt. And the current ranges of the diodes are from 10 amps to 100 amps. And in MOSFET, as on today, 17 milliohms to 750 milliohms is where the catalog is, but then we are coming up with some of the new parts which have much lesser RDS on. By default, we design the products for the high reliability applications such as automotive. So all of our products is by default is getting automotive qualified, and our 3.3 kilovolt devices are just recently released. We also have a new release with our D square pack 7-leg one. That's a very exciting package because it gives a tab only drain connection in order to maximize the creepage distance. The 5 legs of this is working as a source, so you have much more larger area for the source current flow, which would help you to reduce the parasitic inductance and all that. And there is also an additional leg for the reducing the switching losses in MOSFET, right? These are the product release plans. Some of them are just getting released. I mean, it's automotive qualified versions are just getting released soon. Some of the devices are already released. Now, about the 3.3 kilovolt, this gives us an extra edge in terms of being industry leading catalog size with respect to our SiC parts. We have 3.3 kilovolt today. As I said, we have the lowest RDS on 3.3 kilovolt SiC MOSFET in the market that are all the way up to 90 amps of diodes as well. Typical applications that we have aimed is for the APUs and TPUs in the railway applications, and also for the renewable and grid applications, and medical imaging and power supply applications, and also for the motor drive applications where the high voltage kickback voltage is expected. Right now, about the modules, again, as I said, the modules are typically meant for typically defined with respect to the topology that you use, right? That means we have the modules for the boost converters, for the half bridge, full bridge. There are phase legs available. There are anti-parallel modules available. I mean, the dual source connected type of modules are available, right? It's all meant for the different topologies that you consider in your design. The portfolio ranges from 700 volt to 1700 volt. Our 3.3 kilovolt modules is not yet ready. As I said, the modules highest current capabilities is about 600 amps, right? That's a lot of current that we are dealing with. Modules typically reduces your system cost, not the device cost, but the system cost, by helping you to have the you don't need to have a lot of redundant devices. I mean, it's an integrated one, so you can get your timelines easily managed, because it will be the fastest to market, because the development time is shorter compared to the discretes, and the lowest risk, because as I said, there are a lot of reliability and ruggedness factors that we already discussed, and we have the lowest inductance modules in the market. Let's discuss about that. We have a special package called as SP6 packages, which are meant for the lowest inductance modules and lowest inductance designs. Extremely low stray inductance as less than 2.9 nanohenry. That's dedicated to the SiC MOSFET technology, and it enables very high frequency applications, and it improves the efficiency, and also it enables us to have the very high current application designs. We also have the custom modules. Let's have a look at what's inside our modules. Typically, we have our dies. We have a mix of silicon and silicon carbide dies as well. As I said, the customization of the modules are also possible. And then we have this substrate dropped on top of it. With respect to the material that we use, the performance changes a lot. Typically, we offer very good isolations and very good heat transfers and all that by using the correct amount of the substrates. And all of that is sitting in the base plate, right? So the base plate and the substrate and the die forms the heart of the power module. Rest is about the packaging. Again, the customization is possible on the packaging. And of course, there will be the terminals for the screwing, and the typically modules are screwed to the bigger system, and we made it very convenient in such a way that it has all the required leads and screwing options and all that. In fact, our modules are even offered in the customization. I mean, if the business case is good, then we do the customization on the base level itself. Some of our competitors or our front suppliers in the market, they offer the customization, but only on the packagings, but we also offers on the substrate level. Now, another exciting portfolio that we have is our gate drivers. We are the only semiconductor company today in the world who offers the digital gate drivers for the silicon carbide. What are those? As you see in the picture, the very first picture is actually our core board, which is actually our gate drive one, and in which there is a MCU, there are other power supply components, the isolation components, and also the gate drive boosting components such as capacitors and other drives and all that, right? What it gives an extra edge is that you can interface that to the system, to the computer, in which you will be providing a GUI, which would enable you to control the driver in a very detailed way. I'm going to talk about that in a minute. But then, as I said, this is the only digital gate drivers available in the market. We're there for 700 volt, 1200 volt, and 1700 volt rail applications. And these drivers are coming up or are equipped with a patented approach called as augmented switching. Microchip acquired a company called Agile Switch about a couple of years back, who are only into gate drivers. Can you imagine a company who was only into the excellence of gate drivers, right? So we acquired that, and it complements our silicon carbide portfolio. So what it makes so special, right? Typically, in a high frequency, high power SiC world, there are a lot of gate driving challenges. It's all because of the DI/dt and dV by dt issues, right? You would typically encounter a lot of noise and EMI issues. The short circuit is a problem, then over voltage and overheating, undershoots and overshoots and all that always a problem, right? So with augmented switching, you have all that in control. You kind of reduces all that issues. But without augmented switching, you will have to spend a lot of time to make your gate driving circuitry in a required way, right? Let's look at what is augmented switching. Now, in an analog driver or in a non-augmented driver, that is something that is conventionally available in the market today, it turns on and turns off in a similar way that I've shown in the graph here, right? It's a sudden turn on and sudden turn off, which contributes to a larger DI by dt, right? But then you can't really reduce, reduce its speed or increase the time of turning on and turning off, because then you would end up in a lot of overlapping lows, right? The switching losses and all that. Now, in augmented switching, we do it in a very smart way by taking a dynamic turning off steps, by introducing some steps, right? We call that as augmented switching. And all that happens in a very nanosecond way, right? And the interesting part is that the step size of turning on and turning off, it's in your hand, right? You can control by the GUI, and you can easily manage the turn on, turn off sequences or the steps in such a way that you can keep tuning it till you get the desired performance. And we have seen that it actually saves a lot in terms of the undershoots, overshoots, and other noises and EMI, EMC issues in the system design. Of course, it's a patented technology. I mean, you can't have it luxury of time to turn on and turn off and all that. And you also need a very super fast mechanism for this dynamic turn on and turn off. That's in the board, and you would be getting as a board, right? And probably this is the only portfolio that Microchip sells as a board level, right? Apart from this, rest of all our portfolio is the chips, right? But this is the on a board level. You get the board when you buy it from Microchip. So we have the different gate drivers, which which has generation 1 and generation 2, which also allows you to have the augmented switching while turn on and turn off sequences. This gives you very exciting and interesting results. We have seen the undershoots reduces to more than 80 to 100-volt reduction in the undershoots and overshoots, right? All the detailed reports and test cases and all that's available in our web. And we also would request you to get in touch with us to know about this more. As I said, the gate drivers itself is a couple of hours topic to discuss. But today's idea was to give you the glimpses about our profile. Now, how do you configure that? The driver core is here. Then there is an adapter board, which gets eventually connected to the SiC module, right? So if you're buying the driver code, you would need to have the adapter board. The job of adapter board is acting as a bridge between the driver and the module, right? Because the drivers are typically designed in a core, but then module would typically have a certain packages, right? So then you need to match these two things. So that's what adapter board. We also have a different portfolio. We call it as plug and play board, in which Microchip must have already designed the adapter board, and the core will be part of that board. So what you need is all to buy this just one board, right? You don't have to design your own adapter board. Now, this may not be available for all the module packages, but typically we cover good packaging from almost all of our modules, as well as from our competitor modules. We have designed in such a way that it matches most of them, but there will be exceptions. So in that case, we help you to design the adapter board itself, right? So the scenarios this way that you connect this to the module, and then you connect that to the IDE tool. It could be Picket 4 or any such one, and then you connect that to the Microchip's system, Microchip GUI. The GUI is available in web, and then you can configure everything, right? You can configure all that, whatever you need in the driver to be controlled. So these are some of the screenshot of our ICT tool. I believe I have a bigger picture. Yeah. Now in the GUI, you have the graphical editor as well as the columns where you can key in the required voltages and the time durations. You can also get the reports from the gate driver in terms of the fault conditions, the overcurrent, short circuit current, the over voltage, low, the under voltage situations and all that. So it's a very comprehensive gate driving. I sometimes calls it as a luxurious gate drive technology that we provide, right? You can control everything, and this GUI you can use while you are R&D stage, and then you can fix certain configurations. You can let Microchip know about the configurations, and then after that, for the production, you get that as a ASIC itself, right? Because in production time, you don't have to every time play around with, fine tuning these values and all that. So what we offers is an ICT tool, which is, if you think of an analog driver, you will have to spend a lot of time by sitting with the soldering iron and all the passives and capacitors, resistors, and all that in order to get to the a successful gate driving, right? To meet the requirement in terms of noise, voltages, and undershoots and overshoots and all that. And you're going to spend a lot of time, because during the R&D, you're going to burn that a lot. Now, this gate drivers gives you or eliminates all that steps. So one of the biggest offer that we give to our Microchip customers is that we ensure that you saves at least 6 months of time during the development phase by using this intelligent gate drive technology, right? So that's all I had to talk about our portfolio. Now, before I hand over to my presentation partner, let me also talk a few words about the supply chain. That's again the hot topic of the season, right? So semiconductor supply shortage is going to continue, is what we know, right? It's a unpredictable situation. It's in nobody's hand, right? So we believe that it's going to continue. Many of our silicon carbide customers says that they get 52 plus weeks lead time quoted by the other suppliers, right? That's the information that we have. Now, Microchip we have an initiative called as SiC lead time initiative. This is not applicable for rest of the portfolios, but for silicon carbide, today we have the industry's best lead time. That's about 16 to 20 weeks. I have seen that sometimes we manage within 10 weeks if the volumes are less than 5K. But then in most of the cases, maximum 16 to 18 weeks is where we are shipping the SiC parts, right? Typically on a technical webinar, we don't talk about lead times and supply chains and all that, but that was the case pre-COVID. Now we also need to inform you that we have a very decent lead time. The reason is that I spoke about a lot of advantages, a lot of reliability concerns, ruggednesses and all that, right? A lot of advantages you get by moving to microchip silicon carbide devices. But what's the point if it is not available, right? So we ensure that our silicon carbide products are available within maximum by 16 to 20 weeks. But actually lead times are even slightly lesser than that. So what's happening behind the scene? We have it because we have done a very smart stocking with our distribution partners and in our warehouses itself. We have, as I said, we have 10 weeks lead time for the small to mid-size orders. That's less than 5K pieces. And we have our multiple a dual fab strategy as well as a dual supplier strategy. So the supply chain has two ends, right? One is when Microchip supply to the customers. The other end is when our suppliers supplies to Microchip, right? So that end we had multiple sources, and we have ensured from the beginning that because we anticipated a SiC boom, right? So we ensured that we have the required material in order to supply the SiCs. All right, so we spoke a lot of topic today that eventually evolves to our theme of adopting SiC with ease and also the lowest risk. That's the confidence. Our rugged would eliminate some of the extra components that you need. And we're fastest to the market because we have our total system solution. In the beginning, I also spoke of and Microchip is the only one who has the digital, right? So some of the pointers, these are the slides which we would typically want you to go through when you get the slide deck, because I explained already it in a very detailed way, right? Right. So thanks for listening to me. We will I'll answer your questions in the end. For now, I'm handing over the relay to my presentation partner, Mr. Perumal from Excel Point. Hey Perumal, over to you. I'm gonna keep myself in a mute, and I will move the slides for you. Okay.
Yeah, thanks, Mohsen, for handing over the session and presentation to me. So before going to
Perumal Mushi, yeah, just sorry for the interruption. So before you start, I request again all the audience, if you have still any questions, please type in the chat box, Q&A box, where we will be try to address all the questions at the end of the session. Thank you. Yeah, Perumal, you may continue.
So before we are going to end of this session, so these presentations, I just want to glance you through this microchip tools and reference designs. So, Mohsen, next slide. So Microchip has developed his own analog simulation tool, so which is called MPLab Mindy. So here you can see there is a link where you can download it, which is a free of cost. So this simulation is developed in the environment of like Symmetrix and Simplex, and also you can use the models from SPICE and piecewise linear for your analysis. And there is in this below there are like SiC MOSFET, SiC diodes models, which is already in our portal. You can download it, and which will be added in the future in our Mindy tools, or where you can analyze and simulate it. So by this simulation tool, where you can reduce like time of the design and reduce the risk actually. So before your prototype, you can simulate and just check the reference designs here. So if you need a detailed on this MPLab Mindy course, so there is we have a separate portal like we Microchip University portal, so where you can register yourself and join to this course. It is also free of cost. So as Microchip also has come up with some hands-on to get an hands-on this SiC devices. They have also come up with this, some of the reference design. So they have reference design for AC power factor corrections, which is a three-phase. So Mohsin, can you go to the next slide? So this is called Vena PFC reference design, which is a main basic application they have designed for as you know, this major like now EV is booming. So this is for developed for an AC three-phase AC to DC fast charges. So it is about 30 kilowatt now. So we can scale it up further by enhancing the devices. So mainly there are a few excellent features here. This reference designs, like it has a good efficiency, like 98.66%, and also like a very low TST thing, which is less than 5%. And like it uses our own like digital switching controllers here. So you can see in this there is a separate module for gate driving, which is designed by like DSP controllers. And so if you like if you use a normal silicon like kind of devices here, where will be the size of the device will 3 cost more than this. Here you reduce the like where it is a PFC boost kind inductor applications. So you reduce the magnetic size and EMI filters by the increasing the switching frequency. And as Mohsin is explained, there are many advantages, like with very low RDS on and body diode capability and our ruggedness and stability of the device. You can very reliable device you can that have a design. And other than that, there are like with our like Microchip portfolio, we have like other analog power supply designs, and we have an interface device which is like a CAN transceiver, and like UART, everything we have it. Next, like we have like some of the development kits. So in order to make the design easier and to take it in a very less time to the market, Microchip has come up with some of the like development kit. This is hashtag plus and hashtag, so which consists of an SiC modules and digital gate drivers, and there is also like in we given a GUI interface with that, where you can configure the switching frequency, and based on your requirement you can just change the voltage and current specifications. There's some of the application where you can use it like battery chargers, in solar inverters, and induction machines. Next, like we have like we have a portal where you can for dedicated for SiC, where you can select the devices using our guides. There will be a reference design, evaluation tools. There will be a different column for discrete selection and module selections. And the next slide we have where there will be for a module, if you want to select a module, Next slide, Mohsin. So here you can, in order to select in a module, SiC modules. So in the parallel to that column, we have in Microchip digital gate drivers, so that you can select those digital gate driver itself, which will be easier for your designs and developments. So next, so it last, but not least. So as a microchip, we give a complete end-to-end solutions. So how we go, we are supporting like from the design, like we give the design support. We have all the tools. So I have mentioned like there is a MPLab Mindy, and also like on the software controller side, we have an MPLab IDE. And we give all the basic softwares, and we have also somewhere forums, also online forums, yeah, where you can if you have any design, there will be a design check service. We have a dedicated analog and power design check service. You can go through or the technical support there, and also most importantly, like quality. We have all these ROHM standards of all our devices. And also Microchip, they are very good at the supply chain. They have very good distribution relationship, where this kind of where semiconductor shortage, Microchip is very serving a very in a fast manner with their logistics, and they have their own the production house where all these chips will be manufactured in-house, so that the lead times are very less compared to other competitions with us. And we have product, very good product and technology, which will serve all these. It is not only the power, and we serve all these IoT, automotive, every applications the microchip serves here. And to the next slide. So here I will end it with this end this sessions, and thank you for all of your present. And you can contact through us with the below mail IDs, which is mentioned there. And we have also question Q&A sessions. Definitely we need our questions, and we'll try to answer you.
Thank you, Parimal. Raj, you can probably coordinate the Q&A.
Yeah, thank you, Perumal and Mohsin, for the great presentation. So just addressing the Q&A, one of the quick question is that how the RDS1 varies for the SiC products when the temperature varies. So will it increase or will it decrease? One of the questions.
Okay, yeah. So thanks for the question. RDS1 actually, to be honest, RDS1 has got a very complex curve, not only for SiC, even for silicon also, it's the same thing. But for SiC, it has two aspects to consider. One is the gate drive voltage. If the gate drive voltage is low and the temperature high, then it's a different case. And if the gate drive voltage is high and the temperature is low, then it's all different, graphs. Now, I am assuming a case where the RDS1 at 25 degree is, let's say, X milliohm, whatever it is. The gate drive is at a fixed voltage. In that case, as the temperature goes to the right extreme, the RDS1 increases. As it goes to the negative degrees, till about 20 degree, 25 degree, the RDS1 reduces, but then it increases. So it shows a PTC behavior on the operating temperatures. That is one of the reasons why SiCs are easy to parallel. Now, this is a very different case when the RDS1, when the VGS is a negative voltage, or VGS is less, maybe 10 degree, VGS is low voltage and the temperature is low, right? In that case, the RDS1 shows the NTC behavior. That is one of the reasons why we want to keep the gate to source voltage at 20 volt, right? Let's assume that gate to source voltage is 15 volt, then RDS on can showcase an NTC behavior at some given point of temperatures, right? So so we have to fix one of the thing. One is either gate source voltage or the temperature. So it's easy to fix gate to source temperature, gate to source voltage, so that because temperature we can't fix it, it'll be keep changing, right? So yeah, so that's the answer.
Thank you, Machine. I hope we answered the question. Second one is that some of the products are available with the inbuilt gate driver in the SiC. So do we also have available in the Microchip products, or how to like if not available, in how to complete the design with this lesser time to market or the smaller cycle?
Yeah. So we have at Microchip, we call it as IPS, I believe, Intelligent Power Solutions. I didn't mention about such products in today's presentation because that is primarily meant for aerospace applications, and the military and space applications. It is extremely costly devices as well. So to answer your question, it is available, but we don't have it for the industrial and automotive applications.
Okay, got it. And Machine, just to for the benefit of the other audience, so after these product introduction and the support model and all, so if someone wants to start their design with any of the application, whether it is 2 kilowatt, 3 kilowatt, any power rating, so how the support system will work in the Microchip specifically for the India customers?
Okay, so we can't generalize it basically because customers are at different levels. There will be beginners, there will be mid-level, there will be experts and all that. We are happy to engage with any point of stage. In fact, we would be happy if we can start our discussions in the very beginning where our customers define the architecture. That's the ideal way that Microchip is looking for. But then if customers want to engage us at any point of level, suppose that they have designed a system, maybe using Microchip or without using Microchip, they are at some certain level. We would be again as excited as, in the beginning, like we will be interested to look at the systems there. Now, in terms of engagement process, all that they need to do is to send us a mail, and our client engagement manager will get in touch with them through Excel Point. Excel Point's team can also get in touch with them. Anyway, some of our people from our sales engagement team will get in touch with them, and they will involve the application engineers like me or somebody from my team will join them in terms of the technical discussions. And then we will discuss case to case, and we will take it forward with respect to where the customer's expertise is. In terms of one more point towards that is, very fortunately for India, we have our SiC global development team based out in Bangalore. We are the only semiconductor company who has a 300 kilowatt power electronics lab, right? So we are that capable at Microchip for the high power and SiC, especially SiC designs. So we are excited to meet our customers as soon as possible for any level of support.
Great, thank you, Machine. One other quick question is the blanking time for short circuit protection is also configurable? Blanking time for short circuit protection?
Yes, there is literally nothing left out in such a way that our gate driver cannot configure. The blanking time, the on time, off time, that time, the mid time between the on time, the step size, right? Everything is capable, is tunable, adjustable. Not only that, the temperature trip points, the current trip points, under voltage trip points, over voltage trip points, these are also configurable and configurable lively also. And so there are too many things which is configurable. As I said, it's a luxurious gate drive. So it's a business class gate drive, okay? So you have all the options.
And one of the interesting question, which is like related to cost itself. So Perumal has already answered, but if you would like to touch upon more that, I believe that the cost of the SiC product will be higher as compared to a little higher as compared to the traditional product. But how SiC product will help customers or the designer to lower the overall system costs?
Okay. So SiCs are okay. I will answer this in a it's a two-dimensional answer. One is that we'll take a case study. Second one is I'll try to answer in a very general statements. So SiCs are it used to be extremely high costly about 4 years back. Now for any semiconductor, as the volume increases globally, not only for Microchip customers, for anybody, for all the customers put together, if the volume increases globally, the price will definitely start reduces. Now, due to all this pandemic situations and all that, every product portfolio was actually increased the price because of the different cost pressures at the input, right? Input to any semiconductor company. Not only Microchip, everybody has increased their cost because their internal cost was increasing. Silicon carbide was the only portfolio which actually slightly reduced their price. And for some portfolio, they did not increase the price, but for some, they have reduced the price, right? That's because for the worldwide scenario, SiCs were slightly costly. Now it is further reducing. So if you have tested SiCs cost about 5-6 years back, that's not the case today. I would like to request for a new quote because it is changed. It is further reduced and some improvement has happened. That is first case. Second is on a system wise. What you're doing is actually increasing your switching frequency, which reduces the magnetic size, the number of winding that required to create your magnet, that is reduced. Then the heat sinks are reduced. Sometimes you can completely eliminate the fan, that is reduced. On top of all that, your efficiency is also improved, right? So then I would consider it as an apple to orange comparison, right? Because we are not doing apple to apple comparison. Because you are now talking about 5-6% improved efficient system. Then you can't expect the cost. First of all, you can't expect the cost. Second, we then still believe that it reduces the cost because on a system level, you have now saved a lot of stuff. The semiconductor cost increased, but you have saved a lot of stuff. Now assume that you have done this efficiency improvement in a traction controller in a vehicle, right? That means earlier your car was 300 kilometers range vehicle. Now your car, because the efficiency is improved, your car would become 325 kilometer range vehicle, right? Or you can save the cost in battery and you can keep the same 300 kilometers range, but you can save in the battery side, right? So it's again a complex situation where you want to save or you want to benchmark your system as a different efficient category, right? So these are different pointers towards the cost question from my experience and little that I know. But, yeah.
Right. Thank you for the great explanation, Mohsin. Yeah. So I'd like to again request to all the audience, if there is any question, if they want to speak, then they can raise their hand and our host, I can ask our host to unmute you to ask the questions.
So, Mohsin, there is one more question in the chat box. So whatever lab, the world-class lab we have in Microchip, how customers can use this? Is there an option?
Okay. So one unwritten rule is that you need to use something from Microchip because we will not be able to queue you in a busy lab if you're not using anything from Microchip, right? So I don't think I have to explain that. Second, in terms of process, you have to reach out to, maybe you can you reach out to Excel Point and they'll reach out to us directly. You just have to reach out to us and we can discuss. Now, in terms of the practicality, suppose that you are struggling with some boards and you want to test it and all that, then definitely our lab will be available. We have an internal team who will queue the lab requests and all that. It's basically our own development lab, but then we will queue it for our customers as well, as and when it is necessary, right? So we'll queue it and we will get the time slot, then you can use it. In the lab, we have all the basic equipments. but we only have the basic equipment. That means we do not provide any certifications, right? So you don't have to expect it as that it is like a UL lab or Wipro labs or anything. But of course, we would help you to test the your system design. We have, as I said, a very high capable load as well as the source, the oscilloscopes, and rest of the basic items what you need.
Right.
Great.
Right. So,
And one last question is that it is about the demo board. So demo board, how customers can purchase it? I think it should be available, right?
Yeah, it is available. So one thing that's not available easily is our 30 kilowatt VNA PFC design, because it's an extremely costly one. We don't expect you to buy it. Definitely you can buy it also, but it will be a super costly one. So, and our demo boards are, I think, total within Microchip, we have created about 10 boards or so. I mean, we created many, but the healthy boards are 8 to 10 boards. And all of these boards travel from country to country. So in 2020, about 3-4 months, the board was with us in India. Now it is in Europe because the APEC conference was going on. So multiple boards are gone there. But we can request and we can get it if there is a serious, design requirement and business case and all that. We can definitely get it. Now, apart from this 30 kilowatt board, there are many other boards like our gate drivers board. There are other SiC base boards and all that, which you can buy it either from Microchip direct, or you can reach out to either Excel Point or to Microchip. We will jointly do it in a, do the procedures to get that. I mean, like the raising a PO and getting it done and all that, right? So these are the different methods. So the online source name is Microchip Direct. Not only for the valve boards, you will get all the other Microchip component. Anything that is purchasable from Microchip will be there in Microchip Direct. Be it chip, be it valve board, be it some tools, right? Everything is available.
Right, Mushin. So thank you. Yeah, for the benefit of all, there is one portal which Mushin mentioned, microchipdirect.com. Not only with these products, if related to any microchip product, whether it is a debugger, whether it is a tool, whether it is a sample product, if you want to buy, you can take from the microchipdirect.com. And yeah, if any other questions, please you may ask. We'll wait for another 5 minutes before we wind up the session.
I think questions are almost done. So maybe we can give the email IDs so that they can reach out to us directly.
Yeah, we can go back to the previous slide. Yes. So yeah, just to wind up, I would like to thank to the speakers, Mr. Mushin and Mr. Perumal, and along with him, I would like to thank all the panelists and also to all the participants in the audience for their valuable time to join this webinar. I hope this was up to the expectation and in line with the requirements which you were about to join for this webinar. And secondly, I would sincerely request that please go through all the details which are available on the microchip.com for the SiC products. You can use this product in any of the power converter design, whether it is related to electric vehicle, traction, electric vehicle, power converters, other power converters, and for like you can take use for the railway traction inverters also. Any power application where you think the switching and you need high efficiency, better performance, better ruggedness as compared to the traditional one, you can give a thought to use the SiC products, and you can get back to us anytime. And after this webinar, there will be a survey link. So please fill up that same. And in case of any query, you can reach back to us, right? So yeah, thank you all. Thank you once again to all.
Thank you.
Thank you, everyone.
Thank you, everyone. Bye.